Hi, my name is Logan Hirsch. I'm a software engineer working on containers for Nvidia GPU Cloud Registry. Nvidia GPU Cloud, or NGC, offers popular high-performance computing, HPC visualization, and deep learning containers optimized for GPU-accelerated applications. In this video, we'll demonstrate how to install and configure Singularity, pool and save an NGC container, and run NGC containers with Singularity in your HPC environment. Let's first start by getting our system container ready by installing and configuring Singularity 2.6.0. We'll run this demo on Ubuntu 16.04 in a bash terminal, but the steps should be similar for most other Linux distributions. You can reference Singularity's installation documentation for information on how to install Singularity on your machine. First, we install required system packages. Next, we download the Singularity tarball. Then, we untar Singularity. Next, we configure and make Singularity. Finally, we install Singularity. Let's run a quick test to make sure our Singularity installation is working. You can configure your Singularity installation using the Singularity conf file located at user local etc singularity conf. We recommend setting always use NV to yes. This will make sure that the required flags for launching Singularity containers with Nvidia GPU support are included by default. If you don't use this configuration, you'll need to add the NV flag to all your Singularity run commands. For more configuration options, reference the Singularity documentation. Now that we've configured Singularity, let's go over how to pool a container from Ngc and run it with Singularity. If you haven't already, create a free account at ngc.nvidia.com. The NGC registry today has over 35 HPC and deep learning containers, so pick the one that fits your workflow. For this example, we'll use Chroma. To pool a container from Ngc, we first must have an Ngc API key. To generate an API key, go to the Ngc Generate API Key page and follow the listed instructions. If you forget or lose your API key, you can always come back to this page and generate a new one. Now that we have our API key, we need to configure our environment so Singularity can find our Ngc Container Registry authentication credentials. To do so, set Singularity Docker username to OAuth token and Singularity Docker password to the Ngc API key you just generated. We're now ready to pool images from Ngc. Let's find the Chroma image we'd like to pool. We can do this by opening the HPC section of the Ngc registry and selecting Chroma. The latest available Chroma image will be displayed near the top of your screen, along with instructions for how to pool the image with Docker. The Chroma README includes useful information about the application, how to use the container with Singularity or Docker, example workloads, and more. All currently available Chroma images are listed after the README. I'll run this container on a machine with 8 V100s, so I'll download the Chroma image target in Volta. If you'll be running Chroma on Pascal GPUs, you'll want to download the Pascal image. To pool the image, we run Singularity build, followed by the name of the Singularity image we'd like to save to disk, followed by the image we want to pool from Ngc. Singularity will retrieve the Docker image from Ngc, convert it to a Singularity image, and save the resultant image to disk. Note that we can run this command as an unprivileged user. Now that we've pooled a Chroma container from Ngc and converted it to a Singularity image, we're ready to run the application. For this example, we'll use an interactive shell within our container. The Chroma README shows how to wrap these commands in a bash script for command line execution. Let's download and unzip files required for our test run. From our benchmark directory, let's launch our Chroma container with Singularity Run and the name of our Chroma image. Note that we include flags to enable Nvidia GPUs in your container. If you follow the Singularity configuration notes we discussed earlier, you can safely omit the Nvidia flag. We should now have an interactive shell within our Chroma container. By default, Singularity will mount the current directory and our home directory. We can see the data required for our benchmark run here. Now you can execute Chroma commands as you normally would. If you're following along, you should see benchmark output from our Chroma test completing with various performance metrics for the run. Now that our system is configured, it's easy for us to pull and try out other containerized HPC applications from NGC. I encourage you to take a look at what's available and try running your favorite app.